we've talked about these things called molecules, and we know that these molecules are bound together using covalent bonds. And some of these, we've only talked about some that were very small, relatively speaking. Some of these things are really big. I mean, really big. If you can imagine, each of these little ends are part of the molecule. In fact, some molecules we have to actually draw in kind of a globular form. So they look something like this. And some of these molecules can absorb light. We call these molecules pigments. Pigments are important for light. They give us protection against the sun, in the case of melanin. I don't know if you know this, but we have actually two different color melanins, at least, right? There's a reddish color, and then there's a darker color, right? So, but plants need pigments as well. They have chlorophyll. They have many different kinds of chlorophyll, actually. They have A and B, and there's all kinds of different pigments that they use to absorb light. They use it to absorb light to capture light's energy and make chemical energy. That's what they do. But you guys, you and I, we use pigments to absorb light to protect our skin. Okay, so these are molecules. Well, we can use pigments to paint, can't we? Mm-hmm. Like pigments are used to added to paint, and paints can be all kinds of different colors. And each color is a combination of different molecules that absorb certain lights. I don't know if you ever thought about this, but white light is actually not white. I don't know if you knew that, but it's actually a combination of all the colors: red, orange, yellow, green, blue, indigo, and violet. The colors of the rainbow, Roy G. Biv. So all the colors are in white light. Then what happens is the pigment absorbs something, and and your eye is out here. Your eye is looking into. Your eye is looking into the pigment. The light hits the pigment, and out to your eye comes a frequency of light that's missing one of these or more of these. If it's missing the red, orange, yellow, green, then you get a blue-violet. You get a purple light. So a purple pigment absorbs everything but purple, right? Does that make sense? The color you see is the color that's not being absorbed. The color that you see is because if the light's absorbed, you never see it. So I thought you should think about that when you're looking at things. So that's light. So you have this thing called ink. Everybody here has an ink pen? Yes. Is it black or blue? Blue. All right. So you're gonna use all. You have a red. That's excellent. So you're going to use all different kinds. And you're going to use this ink. This ink is a combination of different pigments. No, it's difficult to get a specific color without combining pigments. In fact, did you know when your printer at home can't make black without using all three of the colors that it has? Even though it has black ink, that black ink won't look black unless you could add magenta and the yellow and whatever the other color is. Because it has to get closer to true black, you have to add a lot of the pigments. You have to absorb all the light. So ink is a combination of pigments. It's a solution of pigments. And what you're going to do is you're going to separate the solutes. What are the solutes? The solvent is something. We'll talk about the solvent in a minute, but the pigments are the solutes. All right, the pigments are the solutes. Those are the things that are dissolved in the ink, and you're going to separate it. Now, there's an interesting thing that I want you to look at too while you're doing this, and you're going to do this pretty much on your own. You have your goggles on. I'm going to sit back here. I'll be watching you. I'll walk around. You're on your own to answer these because you're just going to investigate. You're going to go out and explore. That's what your job is today. So you have some pigments, solution of pigments. You will have some answers, some questions. So you will be taking notes. So I would like to see some reflective thinking. That's my goal for you today. I'd like to see some reflective thought, some questions, some answers. You can come and ask me. You can ask each other. So you're going to have you're going to use two different solvents. You're going to take a filter. You're going to take a strip of filter paper. I have scissors for you. You take a strip of filter paper, and you're going to measure the length. On this end, you're going to tape a pencil to it. You're going to tape a pencil to the filter paper to a pencil. You're going to measure something like, I don't know, you could use maybe 1 millimeter, 2 millimeters, but at some length you can take a pencil and draw a line across. A pencil. This has to be a pencil. Pencils are not going to dissolve in the solvent. So you need a reference line. This is your reference line. That's your reference line. On that reference line, you're going to put your ink, a dot of ink right in the center. Then you're going to take and put this strip into a beaker. Let me use a different color for the beaker. You're going to put it into a beaker. And the beaker is going to have an amount of liquid, of solvent in it. You do not want the solvent, you want the solvent to just touch the tip of the paper. Just touch the tip of the paper. You're going to have two solvents. You have solvent 1. Solvent 1 is water. And, of course, as you know, water is polar. And you're going to have solvent 2, which is going to have alcohol, which is less polar. It's somewhat polar, but less polar. And then you're going to take, so you have 2 strips, one for solvent 1 and one for solvent 2, for every ink you want to test. And you can test as many different inks as you want. You can do all kinds of different trials. You have time. There's plenty of beakers. There's plenty of alcohol. As long as you're not using too much alcohol. Use the smaller beakers because we only have these 2 little bottles. I don't want to have to go and get more. Yeah.
So what exactly are we testing the ink for?
Yeah, I'm about to show you in a sec. But that's a good question. So once that liquid gets into this solvent, gets on that paper, just touching it, the ink is dry now on the paper, correct? Mm-hmm. All right, so this solvent is going to start moving up using intermolecular bonds. It's going to start wicking up the paper, like a paper towel, soaking up water, right? All right, as the solvent gets higher and higher, as it moves up, what do you think is going to happen when it reaches the ink? It'll keep going. It'll dissolve the ink. That's right. It'll dissolve the ink. Well, one of these will dissolve the ink. One will dissolve the ink. And the other won't. So you have to make sure you write down which of the 2, the water or the alcohol, is dissolving the ink. So you have control groups here. We'll talk about that in the post lab. So right now, let's talk about this. So this is moving up. It's going to dissolve the ink. The ink is still in paper. The solvent is in paper. So the ink and the solvent are going to keep moving up. So this dot is going to start to move. It's going to start to smear and spread out. But an interesting thing's going to happen. The different molecules, one molecule versus this molecule versus this molecule, maybe this molecule sticks to the paper more, maybe this one doesn't stick as much, and maybe this one sticks less. So as you move up, you'll start to see bands. You'll start to see a green band maybe, and a little higher you might start to see a yellow band. It'll spread out a little bit, and then you'll start to see I don't know what other color you might have, but you could have all kinds of colors. Maybe a light blue. Yeah, she's my wife. She loves me, thank God. It would suck if she didn't, but that's life. So you maybe get a light blue. Maybe at the end you have a little bit of blue left. I don't know. So you'll get this rainbow depending on how many different pigments. So you're going to discover how many different pigments your ink is made of and what colors they are. And what's dependent here is you're separating these colors based on how they stick to the paper. So this is paper chromatography. Now you will later in the year do another thing called an agarose gel. Sarah has already done it over the summer, where you're going to separate the molecules by the size of the molecule. But we'll talk about that later. All right. This is being separated by how well they stick to the paper, and you're going to go and have some fun doing this. Okay? How's that sound? All right, different inks, but you have to do it scientifically. I want to see reflection. I want to see comparisons. If you're going to make a comparison, I want to see some kind of control group. You have two solvents. You have different inks. You can start asking questions after the first set of results. Okay? Are we all good? All right. Get in your teams, and we'll move on.